Thank you so much for the kind introduction. I'm really excited to be here with my man, Chris the Wiz Alexiak, and we are from AI Makerspace. I am excited to share my screen with you right about now. Voila. And we're off. Okay, so everybody, we're going to talk about building agentic and multi-agent systems. First thing I want to do before we jump in today is I want to give you a couple things as a heads up. And then we'll excuse Wiz before we see him back in a little bit. He's going to be available in the chat the whole time to answer any and all questions that you guys can come up with. This is going to be kind of a whirlwind of an introduction all the way through kind of basic prompt engineering through agents and multi-agents. We're going to do a lot of building, we're going to do a lot of shipping, and hopefully you guys will share about your experience today afterwards. But please do leverage the Q&A to get all of your questions answered along the way. Wiz is standing there waiting, and let's see if we can kind of get him overwhelmed with questions as we go through the day here. Wiz, everybody should probably kind of buckle up here a little bit, right? We're going to kind of go through what it usually takes us 3 weeks to get to in our boot camp course in 2 hours. It's going to be intense.
Yeah, it's going to be fun though. It's going to be fun. You know, it's a lot of information, but we're going to be able to get you to a place at the end where you're understanding how these systems work at a basic level.
And thank you for spending your Halloween with us. Happy Halloween, Wiz. Let's go ahead and kick it off. All right, so with that, let's talk about building agentic and multi-agent systems with LangGraph. But first, for those of you that don't know AI Makerspace, I want to introduce you a little bit to the company and the community so you have a place to go if you're really interested in the stuff you learn today. For 10 years as a university professor, I saw that the only people that were succeeding in a 21st century workforce were those who were learning new things, using those new things that they learned to build awesome stuff, and then sharing the awesome stuff they built with others. It's not degrees, it's not prestige, it's not pedigree, it's making stuff as part of a community that's going to get you to achieving your goals. We are on a mission at AI Makerspace to create the world's leading community for people that want to build, ship, and share production LLM applications, and we invite you to join us. With that, let's get into it. Today, we have a lot to go through, and in a snapshot, this is what we're going to cover. We're going to cover the core generative AI patterns, prompt engineering, RAG, and agents that are going to allow us to build the multi-agent systems we ultimately want to get access to today. We're going to go through the core constructs of LangGraph. We're going to talk about multi-agent systems and multi-agent system frameworks out there, including LangGraph, Llama Index, Crew AI, and the new one Swarm from OpenAI, and just do a little comparison so you guys understand kind of what's happening underneath the hood of all of these is kind of the same thing. We're also going to introduce you to the brand new Agent IDE that is part of now LangGraph Studio at the very end, which requires a Mac. FYI, the rest of this does not. Okay, so with that, let's go ahead and introduce the core GenAI patterns we'll leverage today to build out our multi-agent systems. There's 3 patterns: prompt engineering or prompting, which is all about putting stuff in context; RAG, which is all about giving the LLM access to new knowledge; and agents, which could mean a lot of different things, and we'll cover each of them. When we prototype today, we're often leveraging 4 primary patterns. And we're not going to really dive into the third one here, which is fine tuning, too much today, because we don't need it to build multi-agent systems in the way that we're going to show you today. At a high level, we can think about prompt engineering as all about putting stuff in the context window. We can think about fine-tuning as teaching the LLM how to act, how to behave in a more specified manner. We can think about RAG as giving the LLM access to new knowledge that it was not trained on. And we can think about agents as fancy RAG, or as tool calling and function calling, or React, or all of the above. What's at the center? Well, we'll find out today. These are all patterns. And generally, when we develop prototypes, we want to start with the simplest pattern and then grow out the complexity. We're typically going to optimize what we're putting in context through RAG. We're going to optimize what the LLM input and output exactly looks like through fine-tuning. And we'll typically leverage both along the way. Now, we can also use agents like anywhere, because the agentic reasoning idea is really a pattern that can be applied across any level or any part of our application. But there's parts that will come in, and typically does come in more frequently. We're going to focus on dialing those in today. So we need to use all of this. Typically, we're going to start with a simple prompting approach. We might use prompting to add one-shot, two-shot, few-shot examples. We might do some evaluation, and that might actually be enough for our application. But if we need to go and we need to get more advanced, we're typically going to go do some RAG, add some additional data to our app. We're going to then maybe do a little bit of optimization. What's the chunk size? Is it right? Does it make sense? Do I need to add metadata? Is there anything that I should be thinking about? Then I might go do something like fine-tune an embedding model to really align specifically my retrieval with my data before I really triple down on retrieval, try to enhance it, try to take it to the next level. This is where agents generally come in. This is where I'm going to try to augment retrieval with additional search tools. This is what we'll do today. And then maybe I fine-tune the chat model, the generative model in the end. So when we think about prompt engineering, we have to kind of go back in time. We have to kind of understand that all of this came about in a pretty straightforward way. June 2018, GPT-1 came out, and they were like, yo, supervised plus unsupervised, pretty dope. They were like, if you do unsupervised pre-training before you do supervised fine-tuning, so if you do this unsupervised pre-training and then you do some supervised fine-tuning, what happens is you go from a chart that looks like this. Let's take the green line, for instance, linguistic acceptability. And all of a sudden, the relative task performance, instead of kind of bottoming out here at 0.4, it immediately, with a tiny bit of fine-tuning, goes up to 0.4 and then gets very, very high, close to 100%, with just a little bit of fine-tuning. That was pretty sick, because that started down the path. They said, well, maybe we can go bigger and better with the next model, GPT-2, February 2019. They said, maybe we don't even need the supervised fine-tuning. Maybe we can do all of this stuff simply by prompting, simply by putting stuff in context. GPT-3 came out. The paper was called Language Models Are Few-Shot Learners. And they showed, hey, we can get really good at tasks with just, forget fine-tuning that requires tons of examples, couple examples, one-shot, two-shot, few-shot. And this is more like us, right? More like people. We don't require massive supervised data sets or huge explicit supervision to do simple tasks correctly. We follow instructions pretty well from one another, from our parents. And this is the number one rule of prompting. We want to be very clear and very specific. As we get into multi-agent systems, we'll see that prompting is really at the core of what we're doing. It doesn't get hugely more complex than this, being super clear, super specific. Now, there's a lot you can go into in terms of best practices of prompt engineering. It's beyond the scope of where we want to get to today. The point here is that we're putting what we want in the context window. And what we see when we do that is, instead of having this kind of bottomed out, unsupervised pre-training effect that we saw back in GPT-1, with just a couple examples, one example, we can get huge improvements, just like we saw in GPT-1, with just a little bit of with just a little bit of fine tuning. Okay, so all this kind of sets the stage for the importance of prompt engineering. And it's just about putting stuff in the context window. All right, that's it. This opens the door to RAG. Now, RAG is important because everybody's worried about this problem that LLMs are liars. They just straight look at you right in the face and they lie, like deadpan liars, the worst kind, confident liars. How do we deal with confident liars in real life? Well, we fact check them. And so that's what we do with LLMs. We say, hey, before you answer this question, here's some reference material. Use this. And if you can't find the answer in there, just don't lie to me and tell me, I don't know. This idea of retrieving references, augmenting the prompt, what we're putting in context with references, and getting better answers is the key. RAG can be broken down into two core steps. One of them looks pretty familiar to us already. The first part, though, is retrieval. And retrieval is not new. Retrieval is the same problem Google's been solving for 20+ years. Retrieval is where it all starts. We ask a question, we send that question through an embedding model after we've tokenized it, and that embedding representation is used to look for similar things in our data that we've put into our database. So we've taken our data, we've chunked it up, we've created embedding representations, and we've put it all in a vector store or a vector DB. That's going to allow us to quickly search based on our question for similar stuff. We're going to set up a prompt template, something that says, use the provided context. If you don't know the answer, say, I don't know. And we're going to then take the similar stuff, the chunks, the data from our personal repositories, maybe our proprietary data for a company, and we're going to put that stuff in context as reference material. This is the dense vector retrieval process, and here we see our friend in context learning. This is RAG. Well, almost, because I haven't even used an LLM yet, at least not a chat model LLM. I've only used this embedding model. We have to actually run everything through the chat model now, like your ChatGPT style model, and get our better answer. This idea of retrieval is really important. It's simple. Ask a question, search a database for stuff that's similar to the question, return the stuff. This idea of dense vector retrieval, it just means that we have vector representations that we're using. And this piece, this retrieval piece, is really where we see agents come in, as we'll see. This retrieval piece is so important. As we build custom RAG systems for our enterprises, for our companies, we want to make sure that we're using our source data, keeping it private and all that kind of stuff. But there's a lot of other types of data out there that we can get kind of for free by simply searching the internet. And it's that type of data that agents are super duper helpful with today. After we do retrieval, what's it time for? A little bit of in-context learning, AKA prompt engineering, AKA putting stuff in the context window. So while RAG is giving the LLM access to new knowledge, it's also just retrieval augmented in context learning, putting stuff in the context window. In other words, putting stuff into the prompt, doing little prompt engineering. So we start to see the got the patterns. They're all at play here. Turns out if we do retrieval better, we do better generation. It's the whole idea of RAG. And technically, we can get all kind of wordy about this and say things like context augmentation, prompt augmentation, and just know that all this is talking about the same thing. That's RAG, giving the LLM access to new knowledge, which brings us to agents. Now, agents, the first introduction I'd like to give you is they're just fancy RAG. Let's define agent. This is an AI Makerspace definition, by the way. An agent or agentic system is a system that can leverage or emulate reasoning or equivalent to make dynamic decisions in an application flow. And this application flow piece is important when we're building production LLM applications. So we want to really, really highlight that, as we'll come back to when we get to multi-agents, because multi-agent systems can kind of start to get a little bit out there. A quick note on terminology. These are all the same. Don't let people tell you they're different. They're not. That's all. Let's also take a quick aside. When we orchestrate our applications, we're typically leveraging some sort of core orchestration framework. But all of them can be fit into this kind of this way that we can think about and visualize the up-to-date state-of-the-art LLM application stack. Now, this isn't exactly right heading into 2025. Probably we need another layer of abstraction, another dimension. But it's helpful in the context of what we've learned already. This is from A16Z, and it was written in June 2023. So it's held up surprisingly well. The stack, you won't be surprised to see, is based entirely on in-context learning. This design pattern stack fundamentally is what most applications are built on today, especially production LLM applications. Here we see our good friend again from the GPT paper, Language Models are Few-Shot Learners, May 2020. So there's 3 stages in this stack: embedding, retrieval, and inference. We've already kind of talked about each of these. We can kind of see that, and this might be a little bit hard to read, but embedding is about getting the data in, running it through the embedding model, building a vector DB, and orchestrating somehow, whether it's with Python or LangChain or LlamaIndex or something else. The retrieval process here has something similar, but what we have here is we can actually prompt our way through prompt playgrounds, one-shot, two-shot, few-shot examples, or we see this APIs and plugins here. APIs and plugins, think agents, think function calling, think tool calling. So retrieval is augmented also by agents. This is the core focus of today. Agents come into play during retrieval and during this prompt construction and augmentation, because as we've learned, as goes retrieval and search, so goes generation. Starting to come together, I hope. So while RAG is giving the LLM access to new knowledge, agents are kind of like a fancier RAG. Now, another way you'll hear about agents is that they give the LLM access to tools. Instead of access to new knowledge, they say sort of access to tools. And as we'll see, LangGraph is a way that we can use these tools and agents to solve real problems. So let's do a quick second intro here. Agents is not a new term, it's not a new technology. Some of the implementations we have for LLM specific applications are, this is an old book by M. Mitchell Waldrop. We can think about agents and sort of the promise of AI and agents in very meta ways, like neurons are agents in a brain. Consumers and corporations are agents in an economy. There's all sorts of levels at which we can see this emergent complexity that comes from agents. This idea of emergent complexity is something that's been well studied, most famously probably by Stephen Wolfram. Simple rules taken in sequence over time can add up to extremely complicated behavior. It's not different than evolution itself, right? But let's come back down. How do we get this iteration over time? Well, we don't get it by doing a simple API call. We get it by doing stuff in loops. We get it by cycling through and doing thinking and reasoning at each step. We can think of an agentic tool as a superhero that's got access to tools in their tool belt. And how are we going to pick the right tool for the job? Well, that's where our agentic loops come in. Instead of asking a question, just augmenting the prompt, we're going to ask a question. The agent is going to think, do I know the answer? If it doesn't know the answer straight away, it's going to go take some sort of action. That action is going to then feed back into the set of ongoing conversational context that the agent is considering so that it can reason with additional information. Then maybe the agent's going to decide, hey, I know the answer. But what's going on when we take an action? Well, we might take an action and it just goes to our RAG application. Or we might take an action and we call a function or a tool. We do some additional search. Either way, after we're done, we're going to get some result, some new data. We're going to observe it. We're going to take that into consideration in our conversation thread, and we're then going to see if we know the answer now. Okay, there's one more piece that we need to talk about. A third intro. Let's talk about React and function calling. And let's keep in mind that agents are not a specific thing. Agents are a pattern, this agentic reasoning pattern, or this agentic reasoning action pattern. This is the React paper from October 2022. And interestingly, if we read the paper, we can see that, yeah, we can help the model induce, track, and update action plans, but perhaps more useful today in 2024 is we can allow it to interface with and gather additional information from external sources. That is the key to how we use this kind of thing today. And if we zoom in on React and we connect it to some of the things we already know here, consider the agentic loop once more. Now let's zoom in on the act part of this. When we act, we're actually calling a fine-tuned LLM. I know we didn't talk that much about fine-tuning, but it's fine-tuned for function calling. It's fine-tuned for tool calling. When we look at this reasoning and action 1-2 step, we can actually smash them together. That's function calling. Function calling combines reasoning and action into a single step. And there's so much disambiguation of language that we need to do here. So is function calling the same as tool calling? Yes. Remember, agents today are mostly going to be giving the LLM access to tools. In other words, giving the LLM access to tools via function calling. All right, 4 patterns of GenAI, all patterns, not things. Technically, there's 4 of them: prompt engineering, RAG, fine-tuning, and agents. But we're focusing on 3 here: prompt engineering, putting stuff in the context window, prompting; RAG, giving the LLM access to new knowledge, putting stuff in the context window; agents, fancy RAG, with augmented search, giving the LLM access to tools, the reasoning action pattern, agents, tools, agents, the reasoning action pattern. We can zoom in to RAG. We can see it within an agent. We can zoom in to the prompt template in RAG. We can see prompt engineering. We need all of these things, and we'll use them all. We'll use them all with LangGraph today. LangGraph is going to leverage these patterns and allow us to build language agents as graphs. LangGraph is simply a library for building stateful multi-actor applications with LLMs used to create agent and multi-agent workflows. Let's zoom in on a specific word here, stateful. This is really important because state, or the particular condition that something is in, is key to building complex application flows. There's a number of ways you can build applications in LangGraph. You can do simple LLM calls, you can chain them together. We're not actually at cycles yet. Even at router, we're not sort of quite there. State machines is the step between routing and fully autonomous agents. State machines is where most of the heavy lifting is done today. Because when we do something like an LLM call, it's quite simple. Everything is mostly manual. When we chain things together, that's still true. When we do a routing, we're kind of allowing the LLM a little bit more autonomy. It can decide where to go based on, you guessed it, a prompt we gave it. And agents are sort of this fully autonomous, I don't need any humans in the loop, but that's really hard to get to. For enterprise today, for most applications, we want more control. We want humans in the loop. This is where the idea of a state machine comes in. LangGraph allows us to easily create these state machines by specifying them as graphs. Now, this is actually pretty cool because if you can draw the graph on a whiteboard, you can build it straight up directly one for one in LangGraph. That's pretty epic, and that's not necessarily true with all these different methodologies for orchestration. Let's talk about graphs. You guys know about graphs already. We got nodes, we got edges. Okay, what's a node then? It's just a function call. It's a tool call. And an edge is going to tell me where to pass the state. That's it. So what we do is we set up a state graph and then we add nodes. This together allows us to add cycles to our applications built on LangChain. And so what we'll build today is we'll build something pretty cool. Now, we're not going to set up any simple RAG system or chunk up any data, and we're not going to use any embedding models. We're just going to use a chat model, because what we can do is we can set up, each time we get a question that we want to answer, an agent. Let's call it the OpenAI functions agent. And that agent can go to two different tools. We'll have two tools today. We're going to give it access to DuckDuckGo. Here's the prompt, tool that queries DuckDuckGo search API. Pretty straightforward. And then we're going to set up a custom weather tool. We're going to build a weather news team today. And the weather tool has a bunch of stuff, Wiz will walk you through in just a moment, but we can get the weather, basically. And what we can do is we can leverage this agent to sort of go back and forth and go through the agentic loops and figure out, okay, what do I need to know? What goes in the conversation thread? Do I know the answer yet? Boom, yes, I do. But really, it's not the answer so much that's happening here. It's I'm changing state from input state to output state. This is all happening within potentially a single node. Which node? You guessed it, the agent node. Remember, as goes retrieval and search, so goes generation. So let's see how to set up this first agentic application, search tool, weather tool, using LangGraph. Wiz, over to you.
All right, thanks, Greg. Okay, so I'm getting booted up. We will go ahead and I'm going to share my screen, make sure you can see the notebook, and we're going to work through this first notebook together. Okay, so basically how this works is exactly as Greg laid out for us, right? So we have this ability to create an agent, and that agent is going to be powered by this LangGraph and have access to tool calling. So we're going to work through the notebook, and we're going to pause where it makes sense to pause when talking about kind of how we're implementing this. And again, feel free to smash the chat with questions. Okay, so the first thing we have to understand about LangGraph is that we have this idea of cycles, right, which is enabled through our graph. So we can go around in loops, basically. So Greg gave us a great introduction to this. It's extremely important that we be able to go around in loops, right? So we might want to try again. We might want to continue to work towards a better answer, et cetera, et cetera. So we have to install some dependencies, so we do that here. Okay, there you go. Next, we're going to pass in our OpenAI API key, since we're going to be using OpenAI's model to power our agent today. And then we're going to create our tool belt. And I see some people asking for the notebook link, so I'm going to drop it into the chat. Okay, so we need to create a tool belt, right? So like Batman, we need a utility belt, a series of things that's going to help us to tackle challenges, make sure that we have the right tools for the right job. We're going to need to create a custom tool for this, since the default LangChain weather tool requires a subscription, and there are free services available with decent rate limiting, but we're not going to be spamming the endpoint too hard. So we'll use this Open Medio tool. So what is a tool? Okay, because we're going to talk about it a lot. It's kind of the crux of the thing. So a tool is just a function. So we're going to go through building a tool to give you a better idea of what is a tool. What does tool calling mean, right? So first of all, we have this tool input Pydantic model. So Pydantic is just Python's way of trying its best to have any semblance of typing. It helps ensure things are in the right types. It helps make sure that it's communicated to the LLM what types they should be in. One of the things you're going to notice is that this particular function, right, is going to expect to receive floating point numbers or floats. And, someone has to tell the LLM that. And that's what this Pydantic model really helps us to do, is let the LLM know, like, hey, by the way, latitude and longitude should both be provided as floats. You'll also notice that we have in this field a description, and the description is important because it tells the LLM like what should be here, right? So yes, it's probably going to be able to infer it from the name, right? If you ask for a value for latitude, it will hopefully understand that it should be a latitude, right? But this extra level of description helps. So you'll see a lot of description codes and doc strings, and these are definitely for us, the humans, right? But they're mostly for the LLM. So this is this idea that while we're writing code to do AI applications, we are literally just running. We're writing prompts, right? Like this is a prompt right here. You don't need any specific runtime in Colab, so the free instances will work if you want to run this, since we're not running the model in the notebook. So that's the input. So we've talked about the input to our tool, right? We need to be specific about the input. We need to let the LLM know exactly what kind of input it needs, et cetera, et cetera. So this is important, but the most important thing to consider is we have to have a function that needs calling, or a tool that needs calling. And we're going to say the words function calling or tool calling a lot. What it comes down to is that they are both the same thing, basically. So tools are functions, right, at the end of the day, that allow us to interact with certain services or APIs. So with that in mind, let's look at the function that will act as our tool, which is going to be called getWeather. It's gonna blow your mind what it does, right? So it's going to take a latitude and longitude, and again, we've defined that it needs to be in this format, right? We're going to see how we tie this together, but we know that they should be floats, so we're safe to use our type hints here. The type hints are not explicitly necessary using this method, since we are going to define them very explicitly, but it's just nice for the human brain, and this output should be a string. So inside our tool, which will take a latitude and longitude, we're going to make a request to open Meteo's API. We're going to provide our latitude and longitude, and it's going to return us some payload, which should include information that is about the weather. Okay, so that's the thing. This is the API call, right? We want the LLM to be able to call this API, but obviously it can't call it by itself, so we need to provide it a function that calls the API with the inputs that it dictates. We're going to go ahead and give it a list of all the weather codes. This is just for the function. We're just going to parse them out old school style. And then we're going to go ahead and we're going to get our what is necessary to return our string, which will include our temperature, our wind speed, our wind direction, and our conditions. So that's all this function does, right? It takes in latitude and longitude, and then it returns this string with temperature, wind speed, wind directions, and conditions at that latitude and longitude. That's the whole thing, right? That's what this function does, or what this tool does. Now, what we're going to do past that is we're going to create a structured tool. Structured tools are important because they let us add more structure, surprisingly enough. And what we're going to create is from function. So we're going to create this tool from our function. And the function that we provide as the from function is going to be that getWeather function we built above. We're going to give this tool a name. We're going to name it weather tool. We're going to give it an args schema. So args schema here just means this thing, where we define what schema the arguments should be in, right? The args schema, which is just going to say latitude should be a float, and this is a description of it. Longitude should be a float, and it's a description of it. That's it. Okay, we also have a description, which is going to describe to the LLM when this tool should be called. So if, for instance, someone asks what the weather is, then the LLM will see a tool that has description, get the current weather for given locations, latitude, and longitude. That sounds great. Now, one of the great things about LLMs is that we don't have to provide a lat long for them, right? We can provide like a city name, and the LLM is going to be able to roughly get the lat long correct for us thanks to the training data. We're also going to use a DuckDuckGo search run tool, which is going to allow us to fall back to web searches should we need them. You'll notice that this DuckDuckGo search run, we just do this where we provide the tool. If we look at the source code here, it's basically doing all of what we did for the weather tool, but we wanted to showcase how a tool is. So this is what a tool is. That's it. Okay, so a couple questions. Pandas data frame to a tool is going to be a little bit more complicated. You're going to have to be very clever about the schema there. Not enough time to get into it right at this moment, but you can be clever about it and build kind of Pandas query agent to handle this. I believe both LangChain and Llama Index offer that out of the box. And then how do they get the return in the required format? Absolutely, there's something special going on in this structured tool. which is going to make sure that we're getting the output in what we expect. So it's going to be parsed in a specific method. This is the benefit of structured tool over some other usage of tool where we care about the structures of the inputs and outputs. So we can define those very carefully. All right, so that's the tools. We've got our tools now, and we know what tools are, right? They're just functions. I mean, they're just Python functions that you call and do a thing. And while these two tools go to an API, it doesn't have to go to an API, right? It can just run code, can execute, arbitrary queries for SQL. Like it can do whatever you can define a normal Python function to do, right? That's what a tool can do. And so they're very flexible, very powerful. And at the end of the day, the LLM is just giving the inputs to those functions, or some of the inputs, depending on how you set things up. So we've got our tool belt. We're Batman. We've got our utility belt set out. We prepared for the day. We know what we need. Now we can choose our model. We're going to choose GPT-4o because it's good. That's the reason. You can choose others that include the tool calling API. So you can use Llama 3.1 and Llama 3.2 will both work for this, but we're just using OpenAI's because it's good. Then we're going to do this thing where we bind the tools to the tool belt. All this is doing is it's converting because what we have is some functions, right? But we need to express to OpenAI in the tool calling API, we need to express it in the format it expects. And so this bind tools is going to help us convert from our little pile of functions to what OpenAI expects, which is necessary for determining which tool to use. Okay, so now we're ready to start creating our graph. Start thinking about state, right? Okay, so LangGraph's important unit is state. It passes state around. It's there you go. Okay, so we need to make a state object, something that our graph can use to pass information around, and that's how it goes, right? In this case, we're going to use this agent state, which is going to be subclassing typedict, which is a typed dictionary, and we're going to pass in this annotated list. Okay, so messages is a list, and it uses this add messages operator. The add messages operator is basically just saying, whenever we return a value to this particular data structure, add to this list, right? So instead of say using the replace operator, using the add operator just means that our state just grows every time we add new messages to it, which is useful for the application that we're using it for today, though you can use all kinds of operators depending on what you need. All right, so finally it's time for a graph, right? So we kind of know what graphs are, but we draw in the pictures with the circles and lines, right? Just to make sure that we're fully on the same page about graphs. Symbol graph, we got node, we got edge connects nodes, that's it. Okay. The first thing we need to do when we create our graph in LangGraph is we need to understand the idea of what a node is. And a node is a function. So again, we're right back to function world, right? A node is basically any Python function, like this one, def call model, which takes in state. Important, right? That it takes in state, and it does stuff with state, and then it returns a modification to state. So the thing that our nodes do is they act on state or act with state, right? So our nodes are going to be things that can interact with or modify or exploit state, right? And what we do is we create this call model state node, and then we're just going to use a pre-built node for our tool, which is called tool node, which is unsurprisingly going to take a tool belt and then call tools depending on what tool it should call, right? So the important thing to think about or remember is that the tool node executes tools, and the call model state is the thing that's going to interact with the LLM. So our tool node is like just an executor, and you might have seen that language before, especially in LangChain, right? Agent executor. It is the thing that executes things for the agent Tool node, same. Okay, so now we have our two nodes, which is going to be call model and tool node. And then we're going to create our graph from that. So at first, our graph is a blank canvas. It's got nothing on it. We're just going to initiate it. Now we have this blank canvas, right? So we have this uncompiled graph, which is a state graph, and the state graph uses agent state. Then we add some nodes. We're going to add agent, which is going to be our call model node that we created above, and then we're going to have action, which is going to be our tool node. And now we have a graph that just has an agent node and an action node, and they do nothing, right? We can't get to it. It doesn't go anywhere. It doesn't finish. It's just two nodes doing nothing. If we tried to compile this right now, it wouldn't work. Okay, so we need to add some connections here. We need to add a way to get in. We need to add some paths between these nodes, and we need to add a way out. So let's do that below. We're going to set an entry point, and we're going to call that entry point pointing at agent. So now we have an entry point, which is going to be our input, and it's going to point to our agent. So the first thing that our input is going to hit is our agent. Okay, so that's great. Then we're going to build what's called a conditional edge. A conditional edge is basically just a map between different nodes. So we're gonna come into our graph, and then we're gonna need to go somewhere, right? And where we go is going to depend on what the result of our agent node is. So what we need to do is we need to have our agent node do the thing, right? So the LLM interaction will need to occur, and then we will pass to either the action node or we will finish. So let's look at how we do this, which is basically if there's a tool call in the last message, then we should go to the action node. Otherwise, we should be done. And then we add this conditional edge, which is going to start at agent and then go to should continue. And remember that should continue is just a function that takes in state and then returns n nodes, in this case, one of two nodes. And we can see this expressed here, which is we come in, the agent does something, and then it passes it to should continue. And should continue is either going to say keep going, go to the action node, or we're done, go to the end node. All right, so this is almost done, right? We can see we have a start, we have an end, we have a path. But what happens if we get to this action node right now? Nothing. We would just stop and just, it would halt. It would just chill here forever. So we need to create a path back to somewhere, either end or agent. We're going to go ahead and add a edge between action and agent. So the result of our action can be sent back to our agent, which is going to use that information to determine if we need to continue or if we can end. And that's it. That's the graph, right? So we can compile that graph up, and then we can invoke that graph, and we can see that we have this this flow where we go from the agent to action to agent, giving us our final response. We can also see, if we have a question that has more than one potential response, right? So in this case, we ask, what is the weather today in Toronto, Ontario, Canada? And also search the web for what is happening today in the city tonight. When we look at the actual printout, we see that we go to the action node to use the weather tool. We don't actually see going to the other tool. So did it use it? The answer is definitely it used it. So we have this these events that are occurring tonight in Toronto. And the reason that it didn't get this is thanks to the LCL framework. Because the agent determined we could use this tool, we're actually able to just run them both, which is nice. So they're running parallel basically, and that's dope. That is it for our first agent with tool calling in LangGraph. So I'm going to pass you guys back to Greg, who's going to bring us to the next level, introduce multiple things that we should be paying attention to.
Multi-agent time. Let's go. Thank you, Wiz. All right, so that's why we call him the LLM wizard. By the way, again, smash the chat in the specific Q&A channel. Wiz is available. Any questions you have, even if they're down in the weeds on the code, he'd be happy to answer. All right, multi-agent systems. Now, when we talk about multi-agent systems, it's important to understand that it matters who you're getting your reference material from, who you're retrieving the right stuff from. because it can get super meta, especially when we start to consider like the kind of simulation space of multi-agent systems, when we start to consider the entire body of research that has gone into multi-agent systems over the past few decades, it starts to get quite overwhelming. And we want to sort of reduce that overwhelm for you today. Yes, it's about multiple decision-making agents that can interact in an environment and on and on, okay? But we want to go back to this idea that it's about increasing complexity, and it's not about increasing complexity for the sake of complexity. It's about increasing complexity so we can find simplicity through the complexity. That is to say that if we have a specific task or problem that we're trying to solve, we want to make sure that that task or problem, we're sort of matching the complexity of it with our multi-agent systems. This is sort of the key insight into why you might use these systems today. Let's go back to the definition. The definition that we gave you of agents were systems that can leverage or emulate reasoning or equivalent processes to make dynamic decisions in an application flow. We can extend this quite easily to say that multi-agent systems are systems that can leverage reasoning from multiple independent agents to make dynamic decisions in an application flow. So the question is, like, why would you need more than one agent? You can get kind of crazy here, like, especially if I had AGI, do I really need more than one agent? Well, again, putting the pie in the sky aside, today what we do is we group tools, responsibilities, aka tasks, into specific agents to make it more clean, to separate the prompts so we don't have mega prompts, although we could have mega prompts in a lot of cases, right? Long context windows, sufficiently smart agents. There's a lot of different ways to build things today, but it also really helps to explain what you're building to stakeholders, to your boss, to your venture capitalist, to anybody that wants to understand what it is that you're working on. Your wife, your daughter, your brother, your sister, anybody that's not an AI. It's a lot easier to explain some of these systems when we separate stuff out, a lot easier conceptually. Because we can sort of liken the agent, as we started to do in prompt engineering, to roles and responsibilities and personas that people have. Recall that agents are about tools. They're about function calling. So if that's true with agents, is it also true with multi-agents? Spoiler alert, yes. Now, multi-agent systems are one that have agents kind of set up. And what you often end up having, the most common multi-agent setup, is one where you have a supervisor that acts as a router, deciding which agent to go to at any given point in the cycle, let's say. These supervisor agents are just routers, which means that multi-agent systems are just routers on top of other agents. And these router agents, these supervisor agents, what are they doing? Well, they're just function calling down to the agent that's function calling. So the supervisors are function calling agents, and the agents are function calling agents. So is it just function calling all the way down? Well, I mean, yeah, but we already looked deeper than function calling, right? So we could even augment this a little bit, augment our little turtle meme to say, well, at the bottom, we kind of have this React thing going on. Remember we smashed it together to create function calling in the first place, sort of React in one step. So this is the demystification of multi-agent systems. It's not that complex. And when we build with these systems, we'll build things as we just saw from the whiz. We'll build things that include tools, that include input and output state within a single node. We'll add nodes. We'll add supervision. This is what we'll do in the next piece. Now, before we go to the next piece, it's time for a little discussion. Because there's a lot of ways we could orchestrate agents today. And it's important to understand that there are some core fundamentals at play here. We already have seen that we can use LangGraph to add cycles to applications built on LangChain. It's a library for stateful multi-actor applications, blah, blah, blah. It uses graphs, LangGraph. Let's look at a couple other frameworks real quick. Now, if this is new to you, this is all new to you, like Quing, I see in the chat here, seems like it's pretty new to you, then just try to pattern match across concepts. The implementation, we've got a lot of resources, and we'll definitely get you set up to build, ship, and share something epic following this workshop. But try to listen in here and see if you can take something away from this, because this is something that's not often discussed in the industry. Of course, the number one competitor to LangChain out there is Llama Index. And Llama Index just put out a new way that they orchestrate agentic systems. It's called workflows. And I'm happy to share with you guys that the workflows thing is, again, one of these words that is like a common word that we hear all the time, and then it's described and made up of other words that are also common words, events and steps that we hear all the time. This is the problem with the LLM edge today. There's a lot of words we have to disambiguate. But the reason I'm happy to share this with you is that it is relatively easy to disambiguate if you can get the right lens with which to view these tools. So a workflow is an event-driven approach that uses these steps to control the execution flow. Remember the executor that Wiz was talking about? So if you're into event-driven architecture, if you're familiar with this, if you have background as an engineer, this might feel a little bit more comfortable to you. If you have background as a data scientist, probably not so much. There's two easy pieces here. There's events and there's steps. Remember, we saw nodes and we saw edges from LangGraph. We'll come back to this. Let's look at another one real quick. Crew. Crew just got some funding. Congratulations, Crew AI. They're all about building crews, multi-agent crews. And the crews that they built are made up of, unsurprisingly, agents, tasks, and tools. Finally, there's another one that we saw come out recently from OpenAI, not to be used in production, called Swarm. Swarm also has two easy pieces. It's not nodes and edges, it's not events and steps, it's handoffs and routines. And so I want to go ahead and invite Wiz back up here to discuss a little comparison, my man. I mean, we have these different ways that we could build this weather application that we're looking at today. I mean, is there anything inherently different in all of these, putting aside maybe that Swarm says specifically, don't use for production? I mean, when I look across this stuff, I'm seeing some similarities. I'm sensing some similarities. Who's the leader? Which one should I pick? Why is everybody trying to confuse me?
Yeah, I mean, it's a really good question. So that, first of all, second of all, I think it's actually we're all trying to get to standardized language here, right? We're all trying our very best to get some semblance of a way that's more universal to talk about this stuff. As you can see, we're definitely using different words, right? But we're talking with the same constructs underneath. And I think that's the important piece, where we have this idea of, you know, we know that there's some idea, right, that we need to have like little units of work in an agent application, right? We have to have some process by which the LLM does a thing, or tells us to do a thing, or tells a different system to do a thing, right? And then we have to have plumbing between the decision that the LLM makes for
The
us
reasoning,
or something else.
the decision, the reasoning here, right?
The reasoning.
Yeah.
We have to have something that plumbs that to something that can do a thing, right? So now we have this idea of, well, there's two different things. There's the thing that does, and there's a thing that reasons, and we need plumbing between them. So LangChain was like, well, that sounds like a graph to me, nodes and edges. Llama Index was like, that sounds like event-driven architecture, events and steps, right? And Swarm said the same thing. These are routines that the LLM does, and then it hands off to the thing that does. And this is the idea. We're describing the same constructs here, right? We're trying to nail down the terminology. LangChain going with a very familiar terminology, Llama Index going for a very familiar terminology, Swarm saying maybe we should build some new terminology, but it's the same thing under the hood. And because of that, there isn't a correct one yet. It's what's easiest for you to grok, right? You could say, and you would be wrong literally, but not technically, that there's this idea of events and steps in LangGraph. We're just not calling them events and steps, right? But if that's the way you are used, if that's the engineer you are, right, then it's extremely productive to think of this system in the same way that you're used to thinking. Anyway, I'm not gonna get off the soapbox. We'll get off the soapbox.
I mean, it's good. We got a little soapboxy time here. So wait, okay, so this top row here, then, this is sort of like that which plumbs.
Yes, that which plumbs.
Okay.
That which passes information from one thing that does a thing to another thing that does a thing, right?
Okay. Yeah. That acts, that which.
Yes. That which
but not so much. I like the plumbs better because the node really, to me, signifies the action piece. And again, that's where we're doing the function calling. It's react in one step, so it's not as sort of clear cut as reasoning and action. But when we hit a node, when we hit a step, when we do a routine, we're sort of like, okay, so we go from that which plumbs to now do thing, like come out the sink, just extending the metaphor here, or like come out the bathroom sink, or come out the kitchen sink, something like this. There's some event. Well, it's not an event. No. There's some sort of this is the confusing part, I think, is okay. Backing up, why did we pick LangGraph today?
It's for the integration it has with LangGraph Studio, obviously is a great add, but also because I think graphs are the most visual representation of of agentic systems, and LangGraph is literally building graphs, so there's no mental load going from graph to graph, right? You can, again, we meme about this a lot. You can represent Llama Index workflows as graphs, no problem. In fact, it's easy and useful. But I mean, there is a mental load, right? A cognitive load that exists when you are translating between steps, events, and graphs that doesn't exist with a graph first implementation, let's say.
Okay, so I'm not seeing a ton of like follow-up questions in the chat here, so I won't belabor the point here, and we can get to the demo soon. But I do want to address Derek, since we're here for you guys. Okay, we're not here for anything else. Any questions you guys have today, like, let's rock it out. We'll have questions at the end too if you want to stick around. So he asks about this sort of thing that I alluded to, that, and maybe I'll sort of think in real time here on this, is like, this is where we can sort of think about agents as fitting in, as functions, as tool calling. And the way I'm sort of imagining this sort of additional layer we need is this sort of multi-agent layer, because here it sort of makes it appear to me that we're just hitting a couple APIs. There's nothing sort of fundamentally changed here. But, you know, as I was sort of thinking about putting the slides together today, I thought, well, if this is LangChain and this is LangGraph, I feel like LangGraph is really at the center of what we're doing with the multi-agent systems. When we're not building RAG from scratch anymore, and we're just leveraging augmentation of the prompts through intelligent search and retrieval, this feels like maybe it's a little bit heavy of a way to view the stack that we're using today. There's simpler ways, and they feel to me like they're maybe at a higher level of abstraction. I don't know what your thoughts are on this, but you know, this is June 2023. I mean, this is almost a year and a half ago they made this. So intuitively, it's also pushing me to say, okay, well, what's the new standard here? It's more than APIs and plugins when we build multi-agent systems, in short.
Yeah, I mean, I think those are the simplest, things to consider. But we are now thinking about going beyond just, simple function calls, and what if it's actually a working system with human input? What if it's et cetera, and et cetera? I think that's the piece for me that's really evolving. So yes, absolutely, interacting with APIs is unlimited potential. I mean, human beings have built websites in the millions, just interacting with APIs. So it's a space that's useful to us, clearly. But we can go beyond just APIs, right? We can go to other humans. We can go to other businesses. We can go to everything, right? So it's we can go to other agentic systems, right? The idea is that we are getting so many ways to interact with so many things. We need to start thinking about a protocol that exists or is consistent across different agentic systems in different companies so that they can be compatible, right? We need to think about all these things and be able to move up one more level so that we can do it in a way that doesn't make engineers want to cry.
One more level. That's sort of my intuition here is there's one more level. I can't quite visualize it yet, Derek, though. I'm working on it. So like and subscribe. We'll get it soon. Okay, so we got another question from Tim, and basically it's this question here was, what should I use in prod exactly? What of these tools should I use? There's got to be a best one, right?
I'm biased. The answer is LangGraph. That's I mean, there you go. Quick question, right? So that's it. I believe that it's LangGraph right now. I want to be very explicit that we're saying LangGraph, right? We're not saying LangChain. We're saying LangGraph. LangGraph is the abstraction, I think, that is most valuable now from the LangChain ecosystem when we're talking about agents. I think LangGraph is a extremely understandable way to build these systems. Things like llama index workflows do work in production. They have case studies of them doing so you can use them in prod. But if the question is should use, then I'm going to stick to LangGraph for now.
Yeah. And honestly, there's been shops that are LangChain shops that we've met, and there's been shops that are llama index shops that we've met. And so, if your boss tells you to use one, it's like, well, that's the one you should use. And I'm sure there are also, I haven't met anybody yet that is a Crew AI shop specifically, but I'm sure that will come to pass, especially with their new raise. But Tim's point on here, ease of use is fundamental to what you pick, right? So if you can get it up and running quicker with Crew, and you can demonstrate the app, and you can get in front of your boss and stakeholders, it's like, use Crew, right? Figure out the prod thing when you get to prod, and know you can, we got plenty of content on LangGraph, on llama index. It's the concepts underneath that we try to focus on, so that you guys know that it's not about the framework or tool. It's about under all of the frameworks and tool are the same patterns. Bob just took us there. How does DSPy fit in here? Okay, Bob, first thing is we did a 3-part series on DSPy on YouTube, and I'm still confused about DSPy personally, but how would you say it fits in exactly? We got a nice Q&A session. I'll let it go on for a couple minutes here.
It doesn't. DSPy is not where you want to be reaching for multi-agent workflows yet. DSPy might work as part of some of the nodes, right? It might work as part of a tool, right? But other than that, DSPy is further down the rabbit hole that I think we want to use to add value outside of. If you've already built a tool with DSPy, you can wrap it around, or you can wrap a tool around it, and that will probably be fun, and it will definitely continue to do the thing DSPy does. So that's good.
Okay, I want to go to Daniel's question now, because it's so good, and it's what we talk about all the time when we go to events like ODSC. And the question is, what changed? I thought LangChain wasn't legit, and now we're saying that it is. What's the deal here?
I mean, people have said LangChain doesn't exist legit since it was born. They will continue to say it's not legit. People still say you can't use pandas in prod. People still say you can't use polars in prod. People say you can't use NumPy in prod, right? People say Pinecone doesn't matter. No one should use it because you can use vector databases can just be a NumPy array. I mean,
more context here. LangChain just turned 2. Okay, Harrison just put a thing out, right? And when it was 0, it was worse than when it's 2. That's another piece of context. Okay, keep going.
Yeah, at the end of the day, LangChain is an evolving tool in an evolving space. It's going to have sharp corners, is how we're going to say it. You might find your organization eventually grow out of LangChain as you solidify your exact use case and build, in-house tooling to cover those cases. So absolutely true. That will always be true of every tool ever. But for right now, the idea that LangChain and prod doesn't work is certainly something that people will continue to write blogs about. It gets a lot of clicks, but I don't think it's much more to think about than that.
Here's what struck me is when we went to the last conference we went to, there were people up there that said, hey, last year we tried LangChain and we took it as far as we could, and we decided to build out using the patterns we're talking about today, the Python code we needed ourselves because it wasn't quite there. Now, if they went and tried to do the same thing today, LangChain has gone through the official v0.1, now finally updating all code changes. That happened at the beginning of this year when they raised Series A. They're at v0.3 now. I mean, they're much more mature as a company. It's much more mature as a framework, and it's much easier to get up and running today than it was back when people sort of tried to get it going. And so, in terms of the frameworks, again, just to get back to sort of the storyline here, in terms of the frameworks, it is by far the most mature here. You can just say that is strictly based on when they raised Series A versus everybody else. You can look at it from a lot of different perspectives, but to me, if you're trying to rebuild what LangChain has from scratch, you're kind of wasting your time and money, and you should not do that. Okay, Wiz, I'm going to introduce the next demo, and then we'll have you right back, and we'll continue the Q&A at the very end. Okay, so our build for our multi-agents today is we're going to leverage what we already built, and we're going to build a proper weather news team. So that's going to mean we have a meteorologist, big boss supervisor, and then we have a weather research team, and we have a weather reporting team. Now the research team is the one you'll notice we already built. It's got our weather tool, it's got our DuckDuckGo search. And there we are. We already have this subgraph, if you will. We already talked about it in some detail. Now what we're going to do is we're going to build another team. And we're going to have a writer, we're going to have a note taker, we're going to have a copywriter, and we're going to have a special member of our team that's going to ensure that all weather reports written are very dope. Okay? You could think of this as a quality editor if you're confused on what we mean by high or low dopeness. Now, what we're going to do is we're going to take the supervisor role and we're going to articulate what their job is. Remember, they are simply a router. Your supervisor managing conversation, given the following user request, respond with the worker to act next. When you're done, tell us you're done. Now let's see what happens when we ask for complex things, problems to be solved, and we send it over to a complex team made up of a bunch of different sub-teams. Wiz, show us how we build this big, bad multi-agent system.
Oh yeah, okay, so this is a lot of information coming at you. We're gonna try to keep it processable. Okay, multi-agent workflows. We're gonna build this. So I think, you know, this is the idea of what we're trying to build, and it's fairly straightforward, right? So we have this idea of a meteorologist, let's call them, and they have a weather research team, and that weather research team has these tools, search and weather. And then we have our classic weather report team, which also reports to the meteorologist, which has a writer, a note taker, copywriter, and a dope editor. Okay, so, oh yes, of course, sorry. We'll get the old Linkerino in here. Boom. Okay, so this is all we're doing. There's going to be a lot of code that happens to get here, to get to the end, to get to the big moment. But remember, all we're doing is building this. So we're just having to create some graphs and then attach them. So interdependencies, we just have them here. So just you can install them. Same thing with this. You just install it. We need to provide both our OpenAI key and our Tvili API key. Someone noted earlier that DuckDuckGo is sometimes rate limited. This particular application is probably going to have more requests to the web search agent, and so we do have the Tvili API key. You could use DuckDuckGo here if you don't want to sign up for Tvili API key, but we just recommend you signing up for Tvili. Okay, we need to create a bunch of helpers to make our lives easier and more parsable. So first of all, of course, we're going to have all of our imports, so we import them. Then we're going to create the idea of an agent node. Now, an agent node is this exactly. All it does is it takes state, agent, and a name, and then it gives a result, which is based on invoking the agent with that state, and then it returns a list of messages that you know, have the content, which is the result of the invoke, and then the name. So what this means is that every time we call one of our agent nodes, we have this ability to see, you know, what the final result was, and we know who called it. Okay. Agent creation helper function is going to help us create the thing that goes in the agent node. It's a little bit longer, but basically it's a function calling agent, add it to the graph. We're going to give it a system prod, which is work autonomously according to your specialty, using the tools available to you. Don't ask for clarification. Your other team members and other teams will collaborate with you using their own specialties, and you're chosen for a reason. You're one of the following team members. So each agent is going to have access to an LLM, which it needs, or else it's just a random Python function, tools, which is what helps it, do things, and then a system prompt, which we're going to append this blob to. Then we create a prompt from the system prompt, as well as we add these placeholders, as well as we create an OpenAI functions agent using the convenient create OpenAI functions agent utility function, passing in our LLM tools and prompt. And then we have this executor. The executor is an agent executor. You remember we talked about this earlier, and an agent executor is just something that allows the agent to be able to execute using the tools. So, LLM, typically nodes with LLMs can't really run code, by themselves. They need somewhere to run the code. And so this is what we do. We build the executor to do that. Okay. Now we need a supervisor. Now you'll notice that the supervisor is just a router. That's all it does. All it does is route, right? Because Greg talks about this as a meme, and it's hilarious. So I'll repeat it, right? What really do supervisors do other than route tasks and delegate, right? So this is just like real life, this supervisor just routes to the experts that it needs to route to. There's a lot of stuff going on here, and we see for the first time the actual function definition that we use when OpenAI calls our functions, right? So this is how OpenAI wants this information, right? So this is when we use our bind tools function that we saw before, this is kind of what's being built under the hood. Okay. And again, we return the prompt plus those bound functions plus a JSON output functions parser. All this does is parse the JSON output so that we have it in a format that we find useful. All right, so that's our helper functions. So we have the ability to create supervisors, to create agents, and to create agent nodes. That's all we need. First things, the first team we're going to build is the weather research team. Now, I'll scroll quickly to the top here. We have these two different teams. The way we're going to think about this problem is that each of these teams is its own graph in LangGraph. So we have a weather research team graph, and we have a weather report team graph. So we're going to start by constructing this left-hand side graph, and then we'll construct this side graph, and then we'll tie them together. Okay. I'll scroll back down quickly. All we need to do when we create the initial team is provide some tools. So we're basically just going to rebuild the graph we built in the first notebook in this notebook. So you'll see here the Tavili tool instead of DuckDuckGo. Otherwise, this weather tool is exactly the same thing. When we go to our state, it's exactly what we had before. When we go to add our LLM, we're going to use GPT-4 Turbo instead of 4.0, just because this is a very simple task. Getting it done fast sounds cool. We'll create our search agent, which is going to be powered by our tool, and a research agent, which is going to be powered by the tool. Again, this is exactly what we did in the first notebook. We create now a supervisor that chooses between them, and then we create the graph that holds all of those together. That's it. The graph is a little bit more complicated this time because we have these alternate paths, right? So we have the ability to, basically we have the ability to go to either the weather tool or go to the search tool, which is fantastic. Okay, so we add the edges between our search and supervisor, and we add the edges between our weather and supervisor. Very cool. Then we add the conditional edge between our supervisor and one of the other nodes. Okay, and basically the supervisor is just going to select which one it most prefers. Then we have the ability to set up our graph. Okay, so setting up our graph is easy. We just compile it, done. And then we can look at this absolutely beautiful generated image of our graph. You can see that we have a start to our graph. It goes to the chat prompt template, which goes to chat OpenAI, which goes to our JSON output function parser, which will either take us to finish, which will go to end, or search, or weather. And then those will go back, and then we'll do it again. And then we'll either go to search, end, or weather. And you can kind of see how this is going to work. So this is our research team graph. Let's see it work. Before we can actually use it, though, we need to make sure that we're calling our teams correctly. One thing that's important when we're building multi-graph systems is that there needs to exist a way to translate messages between graphs, right? So we need to go from one graph to another graph, and they might have distinct state. Spoiler alert, they do have distinct state. And so we need a way to translate one state into another state. And so this is what's going to help here. This ability to just take a message and then call our kind of initial graph easily. You'll also notice that this is just a function, and this is just an LCEL runnable, right? You can see the LCEL in the code cell with the pipe operator, and basically this is a good thing to know. Our graphs themselves are LCEL runnables. Their nodes can be LCEL runnables. Therefore, subgraphing is easy, right? Because every graph is an LCEL runnable, and because every node in every graph is an LCEL runnable, we can subgraph to our heart's content. Something else interesting to notice is that we've added this modifier to our LCEL runnable, our chain basically just being our research graph, and this is to do that translation step. We're going to leverage that later when we have to translate to and from our supervisor or parent graphs between our two teams. Okay, then we can run it, get details about the Toronto weather today, explain the weather status in technical terms, and it does the thing. Good job, agent. Okay, now we need to build a report writing team. The report writing team is a little bit more involved, so we're going to create a ton of tools. First of all, we're going to just have this live in a random subdirectory. LCEL runnable is a LangChain expression language runnable. It is a LangChain abstraction. It basically means Python function with some extra steps. But the main idea of the LCL runnables is that they have defined inputs and outputs, and so they're easy to glue together, right? So they're little units that we can glue together into chains very straightforwardly. Okay, we create a random directory, like I said, just to kind of chuck whatever we need to do in here, and then we create a bunch of tools. You notice this time we're using a more simple abstraction to create our tools, which is this @tool decorator, and we just have our actual Python function here. You'll notice that we're being very expressive with our type hinting, and this is again so that the LLM has access to call this function correctly. So this needs to be a list of strings with a list of main points or sections, and it needs a file name, which is a file path to save the outline. And then it's going to return the path of the saved outline file, right? And then inside this tool is going to open our file, do some stuff, and then save it and return the file name. There you go. Okay. Then we're going to create a tool to read the file, right? So because we can create files, we also need to be able to read files. And this is where you can start to see that decomposition occur, right? If we want to work with files, we need to be able to open them, read them, edit them, change them, create new files, potentially delete files, right? So each of these can be a separate tool, right? It's a way for our system to interact with the file system through these tools. So we're going to create a read document file, which is again going to be created with that @tool decorator. This @tool decorator is just a more straightforward way of creating the tool that we saw before. We're very descriptive with our type hinting, And then we have a doc string, which tells the LLM what this tool does. And then we have the work that's done. We do the same thing for writing to a document. And then we do the same thing for editing a document, right? So we have to create explicit tools for each of these particular components. That is what's important to take away from here, is that our LLM can't do anything on our local system unless we build a tool for it to do so. All right, then we have the document writing state. And you'll notice that this state's different to our other state. We have a similarity, though, that we're going to exploit the heck out of later. But for right now, we need the team members and next, but we also need what files are available to our tools, right? So because each of these files can act on a file, we need something to keep track of those files, and we're going to use the handy dandy state for that. Okay, for document writing, prelude function, which is a very verbose way of saying just get all the files that we're currently working on, right? Since we need some way to populate that state, this is what that's going to do. Easy peasy. Basically, we need a way to express all of our available files to our LLM as a string, right? Since it's not going to be able to take, it's not going to be able to know or infer our files without us telling them or telling it. And so this is what we have. Okay. Then we have our document node creation. You're going to see that we just create a node for every single tool. Boom, done. Then we create our supervisor, which can take us to any of our tools, including our doc writer, our note taker, our dopeness editor, and our copy editor. Then we create the graph. It's the same graph construction that we saw before. The only thing that's different here is that we have a lot more nodes, right? So we have to add some more edges. You'll notice too, in both of these examples, that we don't actually have any communication between the nodes. All communication is filtered through the supervisor. So that doesn't have to be true, but it is a good design pattern to filter that communication through something that isn't going from node to node, right? We want to limit the number of connections in our graphs, right? So if you'll permit the scrolling here, we'll just scroll to the top for a second, and you'll notice, right, the meteorologist can only talk to the weather team or the weather report team, right? And the weather research team can only talk to search weather or return to meteorologist. And the weather report team can talk to the writer, note taker, copywriter, dope editor, or the meteorologist, right? But because we don't have kind of tool connections, or we don't have like cross team connections, we're really limiting the number of potential connections. And this is because agents do better when they have a really well-defined limited set of tools, right? So the idea is when we're building these multi-agent systems, we really want to have as few arrows as possible, right? So we have our 1, 2, 3, 4, 5, 6, 7, 8 arrows, technically 9, 10, but we're not too worried about those as they're just chained, right? We're trying to keep the number of arrows low. More arrows basically means more complexity. More complexity means it's harder to build the actual thing. So when we create our graph, this time we just plop all those nodes down, then we connect them all back to the supervisor, and then we have our conditional edge, which is going to go from the supervisor to any of those nodes or our end node. Then we can compile our graph, and we can look at the very beautiful picture that we can generate through a mermaid plot here, which is very nice. We start at start, we go through chat prompt template, chat OpenAI, JSON output function. So this is the supervisor, these 3 instances here, and that the supervisor will determine if we go to the doc writer, note taker, copy editor, dopeness editor, or we're done. And then that's it. So now we can see that thing go by adding the same enter chain option, and then we'll add our authoring chain, and then of course we'll see it in action. It will do some stuff and it will generate a report for us. We can look for our reports in here and see things like this, which is our Toronto weather report, and then we can see that it's been a little bit dopified. Now, what if we want to do this all together? Well, we're going to add that meta supervisor, and then we're going to subgraph each of our full graphs as nodes. So we have our LLM, we have our supervisor node. Our supervisor node is the weather research team and the weather report team. The weather research team is the entire graph. And then the weather report team is that entire doc graph. So remember, even though it conceptually to think about, it might be fairly complex, right? Ideation stage is important here. Actually, writing the code is not so bad because an entire graph can just be a node, right? We do need, though, these two little functions right here, right? They look so innocuous, but they're the most important functions in the whole notebook because they translate between graphs, right? So these kinds of translation functions are going to be extremely important, especially as you build more complex, multi-agent systems with more complex state. You need to really manage how are we communicating between node one, graph one and graph two. How are we communicating between the supervisor graph and the employee graphs? I'm not gonna call them that, but just for funsies. So the way we do that is through here. Our example is very simple. The only thing we actually care about is the messages. And so we take the last message as the output to our subgraph, and then we join the graphs by using that message. So that's it. That's the whole thing. That's all you've got to do, which is fantastic. Then we're going to create our super graph, super as in above, but it's also super. Okay, so we have our add node, weather research team, add node, weather report team, add node, supervisor, and then we do the same thing we did for our research team, except each of these nodes is an entire graph instead of just a tool or a couple tools. And we can finally use our full agent. You can see it go to the weather research team and then to the weather report team, and then finally it finishes, and we get out this post, which is talking about the current weather conditions in Toronto, Ontario, how we should dress in these conditions, additional sunglasses or recommendations based on the temperature, and that's what it do. So that is the entirety of our multi-agent example. It's not so complicated, except it's a lot of graphs, right? And subgraphs. And we're getting into this idea of meta supervisors and things like this. But the actual implementation is very straightforward, right? A graph can be a node. And so if we build a graph that does research and we build a graph that does document writing, we can simply add those to another graph, which leverages those as nodes. Okay, with that, I'm going to pass you guys back to Greg, who will close us.
Now, Wiz, is it a lit day in Toronto with light layers being the dope move? Is that appropriate?
I think that my wife would agree very much with this report. I'm a guy who likes the cold, so I don't need the light layers, but there is wind. I mean, it's not light.
I mean, I would think it was winter already. I mean, it is Canada. 20 degrees, I guess it's C. I don't know off the top of my head, but okay, so we're fact checking, right? We're doing some evaluation here, important to do, especially in these multi-agent systems. There's all this.
It is warm, uncharacteristically warm for the end of October, but it should be still a brisk Halloween evening for trick or treating. So
yeah. So what did you ask for? What did the super agent ask for here exactly? We have a question from Daniel.
So I just trying to know. Write a weather report on the weather in Toronto, Ontario. Please include potential appropriate address. First, consult the research team. Then make sure you consult the report writing team and check for copy editing dopeness and write the file to disk.
Okay.
We still need to prompt it.
Clear and specific instructions in your.
Of course.
Look at that.
Yeah.
Okay. Yeah. All right. So then next up, we're going to show you exactly how you guys can visualize with the latest and greatest tools what the heck you just built. This is the latest from LangGraph, and it's from LangGraph Studio. It's called the Agent IDE, Interactive Development Environment. Now, you might think, like we thought when we saw this, oh, That's dope. It's a no-code editor. Well, it's not, though. What is it then exactly? Well, what it is it's a tool that allows us to sample state. We can interact with state. We can pause and look in, almost like live monitoring of the trace. We don't necessarily see that these agentic IDEs, we've reviewed this one on our YouTube channel. We've also looked at other tools like Agent Ops. They're not trying to replace code editors. They're trying to augment the development experience. Quote, even if, as we saw, most of the dev looks like what we just saw from Wiz. So remember we had a couple of visualizations, simple ones like this. These are pretty cool, and actually we both worked pretty hard on this. Shout out to Wiz building this one, and I built this one in due time and due course after he sort of set me on the right path here. These tools, these IDEs will create this boom from scratch out of the box. So it's really powerful, especially if you don't like creating flowchart diagrams after you're done trying to document all your work. Instead, you just want to go ahead and bang out a sweet viz for the boss, for the board, for whoever you're trying to impress with your multi-agent system. So let's see how we can visualize the weather reporting team directly in a live check the state application. I believe Wiz is switching up so he can do this on a Mac. So this is Mac only right now. It's very leading edge. Let's check it out. Wiz, back to you.
Oh yeah. Okay. So bear with me. We're doing the double. We're doing the double share here. Okay, we're doing the double share. LangGraph Studio. Show this screen. Hopefully you're seeing my LangGraph Studio. Hilariously, I get to check to see if I can see it. I do. I see a bright white box. I'm going to assume that is not correctly sharing. We're going to go ahead and we're going to bear with me for 1 second here.
Bright white box confirmed. Yep.
Confirmed bright white box. We're going to show.
Oh, there we are.
Do you see it now? Okay, hey, perfect. This is what we want. Okay, so check it out. It's our graph. We did it. So how does it work? Well, check this out. We can do things like look at the the prompt here. So what we have is this prompt. Okay, that's great. The prompt's not bad. But what I want to do is I want to showcase an example like this right here. Okay, and we're gonna paste this in. This is the moment that we've all been waiting for. So this is our research team subgraph. Okay, this is just the research team subgraph. And what we're going to do is we're going to submit this message, which is write a weather report on the weather in Toronto, Ontario. Please include a potential appropriate address. Also, what's happening in Toronto tonight. We click submit, and we see running, and we get the beautiful visualization. We went from the supervisor to the weather node. We're going to get some information about the weather. We're going to go back to the supervisor. We're going to see what happens next, right? So for right now, it's just generating. Hey, look at that. Because we asked about what's happening in Toronto tonight, we go back to search, right? And then we go to our supervisor. After this, we'll see what's going to happen. We'll just wait for it to continue to generate since it's pulling OpenAI. We go back to the supervisor and we finally get to the end. Okay, so this is, right? So we got the final one is supervisor finish. You'll notice that we get both the beautiful visualization and we get what each node is doing, and we get what our supervisor wants to do, like next, search, right? So the idea of this kind of IDE is to help us really visually understand. Now, what if we wanted to know what happened in this search node? Well, we can view the output at this checkpoint, right? So we can get exactly what was said. We can also get what the JSON blob that called this was, right? Which is extremely important. It is incredible when it comes to debugging, because we can look at this and say, well, I want to debug it. open this up in Langsmith, would you? And then we go straight to the Langsmith trace, which walks us through exactly what happened and the steps that happened, how long each of them took, where potentially there were shortcomings. Like earlier when I was testing this and I got this this pesky error, right, which helped me troubleshoot the application, which was easy to do thanks to Langsmith. Not only can we see our subgraphs here, like our document team, right, which again, this is entirely generated by the IDE. We have our tools, we can drag them all around, we can look at what each of them does, we can set interrupts on them, right? So if I wanted to set an interrupt on my copy editor, I could do an interrupt before, which would pause the execution when it got to this state. The larger your graphs are, the more they do look like a squid. And then we can see our parent agent, which is this you know, the simple graph is what looks like this, but we know that each of these is its own subgraph. And again, all of this is out of the box provided, right? When we look at the code that we needed to write to get this, it's extremely straightforward. I'm going to go ahead and just zoom in so you can see it, but you can see that in the file system, we just need to provide things in this format. We need to provide this JSON, which is going to describe our application, which of our graphs we need at which step, if we have any environment variables that need to be taken care of. And then the agent itself is just copy and pasted from the notebook verbatim, and we can run this in that, I'll just close this annoying pop-up, and we can run that in our agent IDE, and you'll see the process to get it running is as easy as we go to the folder that contains our multi-agent system that we care to run, and it's going to launch a Docker, which is going to run that, and then we're going to be straight away into our visualization, which is going to be very helpful for debugging. So while this is not a tool that's useful for building these multi-agent systems, it is incredibly valuable for debugging them, for understanding them, for testing them. They keep releasing new features all the time, which is fantastic. So this agent IDE is a really big unlock in terms of trying to make your multi-agent systems better, understanding, you know, how often are we going to one agent versus the other, you know, looking at what the actual input is that causes our system to go to perhaps what we believe is the wrong node, right? So that we can get in there, change the prompt, do whatever we need to do. And then, of course, you can see we have these threads. We can do things like fork the threads. So if I want to do my parent agent, give it the big old blob here, you know, and submit, we can go ahead and get this information back, and I can do all kinds of things, like when I'm just going to let the weather research team finish its thought here, right? But when it's done, I can actually fork the response, and I can look at a different way of doing what it did, right? Which is super valuable. So I can say, okay, what if the input was this? What if the input? So we're going to go ahead and, you know, we can see it here. This is our weather event. We can actually rerun this, or we can edit it, and then we can change what happened, and then we can cause a new fork, right? So all of this brought to us out of the box thanks to LangGraph Studio, which is huge. Okay, that's enough going on about it. It looks cool. It works good. Back to Greg.
Yeah. Okay, so just first of all, that was hype when you first started showing this. So I just want to just point out to everybody in the crowd here, if you can demo this in front of people you want to look very capable and awesome in front of, they will love it. Okay, so keep this in your back pocket. This is an unlock for sure. I want to address Nuno's question here. So do you have an instinct as to why they might have released this for Mac only? I mean, I saw that they were putting out graphs that looked like this a while ago. Seems like maybe it was a tool they were using internally, and maybe just wanted to try to get it out, see if other people found it useful.
Yeah, Mac plays really well with Docker specifically. I think that they're leveraging Docker quite extensively in order to do this, as well as some tools that might not have as robust implementations on Windows. So they're going to have to go more in-house for that. Like under the hood, something called Scalar is running. At the end of the day, they'll port it over eventually, but I imagine their belief, which seems true, is that a lot of development happens primarily on Apple hardware. So that's the easiest thing to say.
Yep. And there we are.
Crossing our fingers though for Linux. Crossing our fingers. It's coming.
That's right. That's right. Okay. Well, I guess it's time to go ahead and close out, and we'll see you right back for Q&A. All right. So now it's time to wrap. And in conclusion, other than seeing that supervisors are just routers at the end of the day, which are just function calling agents, is that really what supervisors are doing? Just sort of function calling. Maybe there's a little reasoning, little action. Well, if that's all they're doing, they better watch out, because it seems like that could be something an appropriately skilled AI engineer might be able to automate. So definitely these skills are worth picking up if you're going to be a developer. But remember, it's not about LangGraph, it's not about Agent ID, it's about patterns, and it's about picking the right tool for the job. You're going to see the patterns everywhere. When we see the patterns, prompt engineering, RAG, fine-tuning, React, function calling, we can see that all this complexity is really built up from very simple things. And we can see the commonalities across LangGraph, across Swarm, across Crew and Llama Index. You're going to see the commonalities everywhere. Hopefully, you will see them everywhere after your time with us today. And if you enjoyed your time with us today, please join our cool, competent community on Discord. You can find the QR code in the slides that I've dropped into the chat. And join us every week live on YouTube. These are the last few events we've done over the past 8 weeks, I guess, 7 weeks, and then one that's coming up. We've been focusing a lot on inference optimization, but we've got a huge library of content on YouTube, and we're live every week. You can join us live next week talking about vector post-training quantization and how we're doing extremely low bit quantization to really, really optimize inference. You can also find us live at ML Ops World in a week and a half in Austin. We'll be doing a large workshop. It won't be too dissimilar from the tools we covered today. And if you're there, come say hi. We'd love to see you. We also have a couple courses that if you're interested, you should definitely check out that walk you through soup to nuts, everything you need to become an AI engineer or to learn what's going on inside of the LLM. And with that, I'd like to go ahead and invite everybody to join our YouTube community, to join our Discord community, and to start building, shipping, and sharing like a bunch of legends with us today. All right, Wiz, it's time for QA. If anybody has some, we got Derek asking about, does Llama Index have a similar studio? Not yet, but I gotta imagine they're paying attention to what LangChain's doing. I mean, we're seeing the studios, like Llama Index does have a Llama Index Studio, right? But it just doesn't have this IDE thing yet. And remember, I don't think we covered it today, but it might be worth you mentioning here was LangSmith was something that you almost kind of showed at the very end, but is connected to this studio idea. What is LangSmith, and how would it be useful for folks out there looking to build applications like this?
Yeah, like LangSmith is table stakes, some kind of ability to see what LLM calls you're doing, how you're moving through your agentic application is just necessary. We're not in 2023 anymore. We're not in 2022 anymore. We're just like, I don't know, some stuff happens. Look at the CLI output, right? We need a way to track and trace what these applications are doing, where they're going, when they're going, why they're going. Tools like LangSmith make that possible. So if you're building these applications, it doesn't have to be LangSmith, but having some kind of tracing or visibility tools, like just literally necessary.
Yeah, and that's what we're seeing in the studios first, right? Like the studios are coming out with that monitoring, visibility, and tracing. And then I would expect, once they get that solid, then maybe you start to see some of this visualization stuff, some of the low code, no code editor stuff. But it's not there yet. LangGraph Studio IDE is kind of leading the way on this.
Yeah.
Daniel calls out your squid comment. What's the squiddiest you've ever seen? I mean, we've had some people in our community build some pretty crazy multi-agent systems, but I don't know. You've probably seen way crazier ones. There's some crazy stuff on the internet with, yeah, where do you want to go with this? I mean,
most agent systems, multi-agent systems, are about as squiddy as we saw at max squidness, right? If we want to use that as a measure. And this has become, because past that, they kind of lose performance, right? So you'll see bigger and bigger towers of squids, let's call it, but
a bureaucracy of squids, let's say. Yeah.
But like you tend to see like maxing out at like 8 tools reasonably. People have done crazy things for sure, but in terms of working systems, let's call it, then we have a very hierarchical structure as opposed to a very flat structure. So I think that's the idea. But yeah, it can get a little crazy a little quickly. The core thing is each supervisor shouldn't be tending to like more than 8 things or whatever arbitrary value you want to decide on based on their complexity. Just because, just like a real supervisor, right? There's optimums. There is a best number of direct reports that's been studied by humans. Same thing is true of LLMs. There's a optimal number of things that report to the supervisor, and so we can keep squidness down that way.
Yeah. And maybe when you get to that optimal, you just try to, then just take the relationship between the two agents to the next level instead. Okay, so in terms of, let's say we build this multi-agent system, we ship it to production, we're creating a ton of value for people. How are you going to go about, to Brandon's question, dealing with cybersecurity issues, dealing with getting something like this through your site reliability team, and like what's the state of affairs with all of that?
Yeah, agents are agents, and prod sec teams and app sec teams are just not friends right now, right?
Yeah.
We have a lot of different vulnerabilities. We have a lot of different places where there are security holes. Building simpler things is easier because there's less of those, and that's a large part of why we don't see these very complex productionalized systems. Even if they were extremely performant, they're very, very vulnerable to various attack vectors. I would say the top of mind things to consider are: where does your data go? How are you securing interaction between various API systems? How are you ensuring some guardrailing of your application as it comes to potentially harmful or malicious interactions? So those are the things that are top of mind, but it's such a complex system that touches so many different things, right? If you have an agent that touches 6 different APIs, I mean, you can imagine your security teams at work just already losing hair thinking about the problem, right? So it's maybe at some point we have to manage these systems like employees, right? They'll have their own IAMs, they'll have their own security
you
compliance
gotta give them
details.
incentives like cash, like you'll see in the crew AI prompts, right? Okay, so in the interest of time, everybody, I'm gonna ask that Wiz goes ahead and addresses Daniel's question in the chat, because we're getting kicked off the stage here. Alana is back. Everybody, thank you for joining us today. If you liked the vibe, the cool, competent vibes, come join our community and start building, shipping, and sharing with us today as we try to build the world's leading community for people that want to build, ship, and share production LLM applications. Happy Halloween, everybody. Alana, back to you.